quick class on Chapter 3. We are talking about protocols and communication. Protocols are basically ways you set up how you talk. Right now I'm talking to you. The protocol I'm using is English. There are other languages out there, Chinese, Spanish, French, Swahili, whatever. They make sounds just the way I do. They have symbols just the way we do. In some cases different. They should look at Chinese and more older languages. But those are the protocols. Those are the structure for it. The sounds don't mean anything until they're put into an orderly form. So we're going to talk about that. I'm going to do this. Communication fundamentals. As I was saying, human beings communicate. You talk. It goes through the air. The person receives it, and they're their destination. Computers are much the same way. You talk, it goes through the line, they receive it, and they read it. Now this can be different. For human beings, this can be air, this can be written, this can be hand signals. Computers, fiber, Wi-Fi, copper, that you're most familiar with. So the medium is the way it transfers, is the environment that it transfers. Here, look at this, read it a little bit. It doesn't really make much sense. It's English, not using capitalization, spaces are wrong, spelling is bad, this is Portuguese. But if you translate it, put it in the right protocol, it makes sense. Now on Translated, we can sort of make sense some of this to a point because human beings are flexible like that. Computers are not. They have very specific, expected things. If they're not there, it doesn't mean anything. These are all things that make up what protocols are. Timing, size, formatting, encapsulation, encoding, delivery options. We'll go over them. Coding. Message source, the person. They're encoding it using words, transmitted over the medium, the channel. The person receives it, so on and so forth. Now, encoding requires references. You need the same language. I mean, we all have explained something to somebody and they didn't understand it. I might be doing that right now, who knows? Because we don't have the right references. So a lot of this class is really going to be teaching you the references. Takes it, encodes it, sends it, decodes it. You don't take that picture that you have on your screen, that little GIF or JPEG you have, and send it as one giant file. It's broken down into bits. And then you need to set that in certain formats. A good example is a letter. Take a look at your letter. We have certain formats: sender, recipient, postage. The letter's inside the envelope. You break it down into certain things. Envelope requires recipient, requires source, so on and so forth, all the way to the end. Right there. There we go. As you can see, it breaks down the different parts. Networking is no different. And you'll notice here's the big thing, is the message does not need to be read in order to send it to a location. Your postman does not need to open your letters to send it to you. He doesn't need to know what's inside. Messaging is much the same way. The internet is much the same way. They don't need to know the routers and switches that we learn about in other devices. Don't need to know what the message is in order to send it, route it. Now we can do that, yes, but it's not necessary for routing traffic. Now, again, size. These are one of the rules, part of the protocols. If I talk too much, your eyes will glaze over and you'll stop paying attention. I know that because I do it myself. Everybody's that same way. So we have to keep the size limited. Sentences, pauses, the fact that these videos aren't going to actually be 15 minutes long. Pieces are the same way. They don't send that giant picture in one giant package. They send a bunch of smaller ones where your computer puts them all together, and then you see the picture. That's why your computer has to work even when it's messaging. Old PCs have to work really, really hard because of that. Access method. Is the other person busy? Well, you don't talk to somebody when they're on the phone, do you? Because they're already in another communication. So they're already communicating, they can't communicate. That's why we have, what they'll often do is interweave, talk to one thing, then talk to the other, then talk to the other, then talk to the other, go back and forth. Humans can't do that very well. PCs can. Flow control. Speed and how much. How fast? Some people need less. Some people like it faster. Some people like it slower. Bigger sentences, smaller sentences, certain words, this, that, and those things. Then response timeout. Are they listening? Come on, let's be honest. We've all got bored with somebody and wandered off. Sometimes they don't even notice. Well, response timeout is the noticing that, hey, somebody's gone. Delivery options. Alright, there's 3 big ones. Unicast. That's me talking to one person. Multicast. Me talking to a couple people. Broadcast. Me talking to everybody. So, you have a live stream at school. You walk in, your buddy's there. You and your buddy are talking. A couple other buddies pop in. You and the other buddies are talking. And you see everybody else in the room talking as well. Well, the principal walks up to you and goes, you and your buddies talking. He's multicasting. While there's other people in the room. The principal walks up to you and goes, hey, whoever's listening to this video, you are now going to give a speech in front of the entire auditorium. Congratulations. After you stop crying, you pick yourself up, walk up on the stage, and give your speech, which will be a broadcast to everyone. Not that's the way it really happens. Here, a quick little video. Unicast, 1-to-1. Multicast, 1-to-multiple. And broadcast, 1 to everybody. Rules, content. What are you trying to get to them? Where's the cafe? Well, getting that idea, that concept across can be done different ways. The rules layer. What language are you using? Are you saying French? Are you saying English, Spanish, whatever else? You go to a foreign country, you're not using the right rules, this concept doesn't get across to the person. And then the physical layer. Are you writing it down, or are you saying it? Are you doing Pictionary? Network protocols. The data. The routing information. How it goes through. A is down. These routers talk to each other, let each other know what the path is. It's not much different than knowing where the road construction is on the highway. Much the same way. That's what the IP for. Well, that's what the routers are for, is give that information. They're the cops, pretty much. Let me see how far we have to go. Alright, we can finish this. So, we'd have different layers. Break this down in different layers because human beings can handle thinking all of it in one chunk. And because if you mess with one layer, you don't mess with the other ones, so it limits the damage and, easy to work. It's like a car. You can work on a transmission without it affecting anything else. You can replace the transmission without affecting anything else. Make it better, so on and so forth. HTTP, your website. TCP control, this is, how big, flow control, things like that. IP is the routing. What's the address? What's the destination? Ethernet is the physical part. We'll go over this more. These are all sorts of protocols that are used. Start memorizing them. I'm joking, don't. These are the ones you need to know. Novell, AppleTalk were proprietary ones that lost out hardcore. ISO is basically these, just international. So it's this, but they like to tack it on as international. Whatever. Same thing. This hasn't changed over any of them. Again, we'll talk about these a little bit. TCP IP. This is the internet. This is what you use from what you think of the internet. The internet is more than just this, but this is the part that you use in the day-to-day. So, www.com. Or www, not .com, just www. That's when the websites, what you're looking at right now, what you're using to go to this class, and you use every day to watch your little cat videos on YouTube and all that stuff, started with 1991. 2 years later, they had the first Mosaic, which is the first web browser. Mosaic's still around, they just have updated versions. And this is IP version 6, you'll see this later. 1995, 21 years, still haven't fully implemented it. We're still using version 4, that's what you're going to be taught. Still like a little bit of version 6 later on. Still pushing version 6. Protocol suite. Here you go. One of the suggested things is to go through and write down each sentence about each one of these protocols. I suggest you actually do that. It will help you remember them. Because you will use every single one. You do use these every day. You use all of these. I know what they are because I know how to configure them somewhat. I'm not an expert at any particular one. It's not my job. I know a little bit, a lot. So this is encapsulation. This is the big thing here. Messages here. And then the outer parts formatted for certain things. This is over the physical link. This is the routing traffic. This is the flow control and what language. This is the program, the website. This data is for a website. And the other way, again, watch this on the other part, is it broke it down the other way. So the data on the inside, you build it up as you go across the medium to get more information. When you get to the other side, you tear it down little by little. This way, for ICP and TCP, if they need to route it, they only have to go to here, then they put you back on and move it to the next destination. You never actually have to worry about this stuff on the inside. It doesn't affect you. It saves programming time. Give this a try. This will actually help you quite a bit. Open standards. There's two types of standards, open standards and proprietary or closed. Open standards are available, are run by nonprofits, and they're available to everybody to give input on and modify. Well, you can't really modify, but you give input on them. They usually have a part that can be publicly modified for your needs. They typically run the internet. I don't really know much about these stuff. ICANN and IANA, these are the two big ones that do IP addressing, domain names, and port numbers. They're nonprofits. They keep these things organized. They don't really own the internet. They don't control the internet. They keep things organized and everybody on the same page. IEEE, this is your Wi-Fi stuff. Wireless LAN, yeah, everybody's wondering about this stuff, right? This is your cabling standards. These are the standards that we, again, work by. Not required to. You can do different ones, but this way everybody knows the same rules, and you can communicate. AKA, you have the same language. Reference models. We'll stop here for this video, and then we will continue on next video on reference models. Yeah, we'll do the next video on reference models. So.